This is AGNR 131 Soil Science Lab Exercise 3, Part 3, and we're going to talk about particle density today. We're going to do a little demonstration on particle density, and you'll notice in that I'll talk about it in a lecture, and also in your lab write-up or lab handout. There's a little bit more information on that. This is just going to be the procedure, but I'll give you a little bit of background so you understand what exactly we're doing. So particle density, you might have heard of particle density and bulk density together. They're both similar, but yet they're slightly different. What we're looking at with particle density is the actual density of just the particles in the soil. And if you'll remember from lecture, lab, and me yakking constantly about it, the particles in the soil are sand, silt, and clay. So what we want to know is, what is the density, or what is the displacement, if you will, which is going to give us density of the sand, silt, and clay particles in our soil sample. We can easily do that, just like you can figure out how much volume you displace by measuring the water in a bathtub and then jumping in it and seeing how high the water goes. We're going to do exactly the same thing with our soil sample. We're going to have a known weight of soil sample, just like you know what you weigh, and then before you jump into the bathtub, we're going to put in a known amount of water. You could do the same thing in a bathtub, put in an exact amount of water, and then measure the height before and measure the height after. That's going to be the volume that's displaced by the particles, the sand, silt, and clay in our soil. It's a particle density. So it's a pretty simple procedure. It's not 100% accurate because there is going to be some air trapped. There's going to be some very small particles of air trapped in there that we're not even going to be able to see. We're going to try to eliminate that by tapping our sample and getting all the air bubbles that we can out. But for our purposes and for most purposes, if you wanted to know the particle density of your soil, this is how you could easily do it. All right? All right, so what I've got in front of me while we were off, I went ahead and I weighed out exactly 20 mils of water. We're going to run two samples. 20 mils of water. I don't know if you can see that. I put it down there so it's accurate. 20 mils and 20 mils of water. I've got two samples here, exactly 20 grams of soil. They're the samples we've been using kind of all along here. I've got some parafilm, which I'll show you how this works, but I'm going to seal these tubes and tap them, make sure I don't spoil anything or don't lose anything or water or whatnot. And then I've got two syringes here with 40 mils of water in it. Now, you're going to see why I'm going to need those in a minute, and they're exactly 40. So I've got exactly 20 mils of water, exactly 20 grams of soil, which I'm going to pour in here, and I've got exactly 40 mils of water that I'm going to use to rinse the soil off the sides of this. So I'm going to know exactly how much water that's going to actually go in here, right? And I know exactly how much soil. So what's going to happen here? If I do this right while I'm on camera, I'm going to pour my 20 grams of soil very carefully into my 20 mils of water. And if I can do it right, I won't get much on the sides. And I won't lose any. All right, so a little tap there for the 1/1 millionth of a percent. That's empty. So I've got one there. All right, now I'm going to do the same thing with this one. 20 grams of soil and 20 mils of water. Right, now I'm just going to tap these right now. Just get them down there, but you can see that there's some of my 20 mils that's stuck here on the side. So I'm going to carefully use this, and I can use all of it, it doesn't really matter. I'm just going to go around the side here, and if I'm really good, I can stop at, say, 20. I probably want to use 20 or 40, but if I can visualize this, I'll probably stop here at 20. Just to make it easier. But you need to use 20 or 40 to rinse your sides down. I've got a little bit more. I can see that. My sides are pretty good there, and I've got 20 mils left here. So I'm going to go ahead and use my 20 mils on this other one. So now what do I have in this one? 40 mils of water, 20 grams of soil. Do the same thing over here with the remaining 20. I think I can get all this maybe. Come on, baby. Get it all down. Yeah, okay. So I've done this. I don't need that one. I'll put this one here. I don't need this one at all. Can I itch my nose? Now what I'm going to do here is I am going to actually shake all that up. So it looks like the water and the soil sample is all mixed together, but we don't know that for sure. So let's make sure if I can get this top of this parafilm thing off. You can pause it. Okay, I finally got the parafilm separated. So what I'm going to do is, this stuff is actually kind of stretchy. If you're careful, you can stretch it. It's like really thick, waxy cling wrap, if you will, and it'll stick to this. If you pull it too hard, it doesn't really stretch too much, but if you do it just right, you can actually make a nice seal on it and then push the edges down. So now I've got that seal. What I can actually do is, if I dare, I can actually shake this thing up, right, and it won't leak if I've done it right. So now I got the whole soil sample mixed up there. I'm going to take my chances with this one, make sure it looks good, and I'm going to do the same thing with this one. Shake it all up. All right, so now you can see I've got some sample there on the side again. So what we're going to do with that is, I'm going to go ahead, I mixed it up. I probably should have done that before, but it'll work this way too. I'm going to try to add another 20 to this to get all those particles down on the side. All right, so another 20 on this one, and then I'll be back and show you this in just a second. Okay, so we've added, after I tapped it and shook it, of course all the soil particles went up on the side, so I added another 20 mils of water to each one to bring those particles back down. You can still see there's a little bit of debris sitting here on top, some particles that haven't quite didn't want to sink, or some perhaps some organic matter. But we now have 60 mils of water in each one of these samples and 20 grams of soil, so everything has been done exactly the same. So if we know exactly how many grams of soil, 20 grams of soil goes in there, and we know how much water we've put in, we know we put in 60, what is it reading right now? Well, this one right here on the left, which is a sandier soil, is reading 69. So 69 mils, but we've only put in 60. But we've got 69 displacement. So that means that 20 grams of soil displaced 9 milliliters worth of water, because otherwise it would, if it didn't displace anything, when we put 60 mils of water in, it'd be 60, right? But it's 69. Over here, this soil here seems to be more clayey, but it's only reading 67. So again, 60 mils of water was put in here, but the water and soil mixture together has gone to 67. That means that this particular soil sample has displaced approximately 7 milliliters of water. That's your particle density. So now we can easily make a calculation, right? If we know that it's that any kind of density is going to be weight over volume, right? Weight over volume, we can calculate what the particle density of these soils is, knowing that the weight of the soil was 20 and the volume displaced was either 7 or 9 in this case. So by doing a simple division problem, we can actually calculate the particle density of any soil sample by doing exactly what we've just done right through here.